in the given network, determine the reading of the milliammeter. Now you take down the network. Here is a given network. (20 ohm), another 20 ohm, and to this we have a ammeter. Then we have a 60 ohm resistor, (4V), battery of 4V. We have another battery of 5V. And given this is point is P, Q, R. Yes. Determine the reading of ammeter means you need to find out what is the current flowing through the branch PR. That is what ammeter will read, and the value of this also 20 ohm. So we need to find out what is the current flowing through this 20 ohm resistor that is connected between P and R. We can use Kirchhoff law. So before that, let us assume the currents in each branch. Let me say this, the main current I, and the current through branch PS is I1. So according to KCL, Kirchhoff's current law, the current to this branch will be I minus I1. I will write here I minus I1. This current is I minus I1. So the ammeter will read the current I minus I1. We need to find out what is I minus I1. We'll apply KVL to the loop 1 and loop 2. Okay, so apply KVL to the loop. I'll take first loop as PSRP. Now apply KVL. So first we have 5V. I'm going in the clockwise direction, so that is -5, -5, -20 I1, plus 20 I minus I1 equal to 0. Now simplify this. -5 -20 I1, and here again -20 I1. That will become -40 I1 plus 20 I equal to 0. Or further simplifying, 20 I minus 40 I1 equal to 5, or divide this equation by 5, we will get 4i minus 8i1 equal to 1. Let me call this equation as equation 1. Now consider another loop and apply KVL. Consider loop PRQP. We have 20 ohm, so let's go in the clockwise direction. So it will be minus 20 into I minus I1 then current to 60 ohm as I minus 60I and current to this and then we have 4-volt battery, so plus 4 equal to 0. Now simplify this equation. 60I 20I minus 80I plus 20I1 equal to minus 4, or 80I minus 20I1 equal to 4. Divide this equation by 4. 4 20s are 80 minus 4 5s are 20 equal to 1. Let's call this as equation number 2. Now by considering 1 and 2, solve for I and I1, because we need to find out what is I minus I1. So equation 1 minus equation 2 will give us 4i minus 20i minus 16i minus 8 minus 5, that is minus 3i1 equal to 0, or I is 3 by 16 I1 minus I is minus 3 by 16 I1. Now substitute the value of I in equation 2. Substitute I in equation 2. So we get minus 20 into I, that is minus 3 by 16 minus 5 I1, 16 I1 is there, minus 5 I1 equal to 1, or I1 is, simplify this, we get 20 into minus 3 by 16, which is equal to minus 3.75. I1 minus 5 I1 equal to 1, or I1 is equal to minus 1 divided by 8.75, or this is equal to minus 0.114 amperes. I1 is minus 0.114 ampere. From this, find out what is I. I is minus 3 by 16 into I1. Therefore, I is minus 3 by 16 into I1. Substitute the value of I1. Minus 0.114. This is equal to, do the calculation, you will get 0.021 amperes. So I is 0.021 amps. Now the required value is I minus I1. Let's do I minus I1. That will give us the reading of the ammeter. Reading of ammeter or ammeter reading. Ammeter reading is equal to I minus I1, which is equal to I is 0.021 minus of 0.114. This will be equal to 0.135 amps, or the reading of ammeter will be 135 milliamps. The ammeter will read 135 milliamps. 135 milliamps. We used KCL and KVL or Kirchhoff laws to solve this sum.